day everyone, and welcome to today's physics class. In today's class, I want to discuss velocity time graph with us, analysis of it. Don't hesitate to share the video. Don't forget to subscribe to my YouTube channel, Physics and Mathematics Lovers. If today is your first day of coming across this video, just hit like, follow, and also comment. Now let us look at velocity time graph. Velocity time graph is very useful in physics. So, in the sense that it gives us more information about the motion of an object. So, the motion of objects can form different kind of shapes. Can form a square, can form rectangle, can form a triangle and trapezium. Now, let us look at the graph. The graph is usually like this because we are plotting velocity. This is velocity here, velocity in meter per seconds. Then we plot it against time. This is time in seconds. All right. Now, if the object accelerates from rest, that means the object is at rest and it decides to move from rest. So if the motion will go like this, then if it get to a point, the velocity will become uniform because the velocity is here. It will increase from here down. Coming to this point, it begins to move uniformly. Then it can come down. This is at the point of deceleration. This is deceleration. So this point here is O. Then we'll call here A. This is B. Then this is C. We can trace down here. Also trace this place down. Okay. So this is D and this is E. Now, the slope of velocity time graph gives us the acceleration. This is where the acceleration is observed. Look at it here. At this point, the body begins to accelerate because we said our acceleration is what? Increase in velocity all over what? Time. That means V minus U all over what? Time. That is your A. That is your acceleration. This is where we have acceleration. Now, at this point here, the velocity, this is your final velocity here, because the object starts from 0 here. At this point, velocity U is 0. This is for what? Object that starts from rest. Now, at this point here, this is your V. Then the object continues to move uniformly. On getting to this point, the velocity begins to decrease until finally the V here, at this point, V becomes 0 because the car has what? Decelerated. It could be some certain reasons. Brake is then applied. When the brake is applied, so the car cannot stop once. So when the brake is applied, see that the velocity will reduce to this point. Then as you apply more brake, then it will reduce. Eventually, the V becomes what? 0. So at this point here, we call this place deceleration. This is deceleration. Deceleration or retardation. Deceleration or retardation. And here, this is where we have acceleration. Acceleration. And let me tell you, deceleration and acceleration, they have the same value, but opposite. So this one is negative acceleration. Retardation, we call it retardation or deceleration. Now, if we want to calculate the total distance is the area of this trapezium. Look at here, the whole of this trapezium. That is the total distance. Now, acceleration here, if we want to get acceleration, this is where we have acceleration. It is the slope here. The slope here, that means we're having A, which is acceleration OA. Acceleration here is the OA equal to then AE all over OE. That is where we get our acceleration. And this is when we have the time T1, this is time T2, time T3. Now, for us to calculate the retardation or deceleration, we have it here. So which is now BC. BC is the retardation. BC equal to, we have BD or DB all over. Look at here, we have DC or CD. So that is the retardation. Okay. Now the total distance will now be the area of this trapezium. And of course, we know the area of trapezium. So the total distance is S equal to half into, look at this line here, AB plus, look at here, OC, then multiply by the height. Look at the height here. This AE is also the height, and BD is the same. Since this one here forms a right angle, this is a rectangle here, then times AE. So this is how we calculate the total distance, the acceleration, the deceleration. So from the velocity time graph, so the whole of this information can be gotten from there. Now, this particular shape you are seeing here, this graph you are seeing here, is where the object starts from rest. What if the object does not start from rest? Let's assume it starts from at a point, initial velocity, which is what? U. Now, let us look at how we can get the total distance from there. Now, if the object is said to start from at a point, let's say this is U, this is where the object starts, and as it starts, it begins to accelerate, and getting to a point here, it maintains the final velocity. This is the final velocity here. Okay, it will maintain the final velocity before it comes to rest finally here. All right, so now at this point here, we have here, trace here down. Okay, we also trace here down. So now this point here is your U, okay, and this is your final velocity. And at this point, we have our acceleration here. We have acceleration here. It can call here P. We can call here Q. All right. Okay. Okay. Let's see. Call it A. Let's say A. This is B. Then this is C. This is D. And this is E. So we already know that to get our acceleration now at this point, to get acceleration, it's no longer the slope anymore. So this is where the slope will now lie. Look at it here. To get acceleration, this is where the slope will be from here to here, which is now what increase in this velocity all over the time it takes to get to this point. Now, for us to get the acceleration here, now we know that this point here is your final velocity, and this is your initial velocity. So our acceleration now will be equal to V minus U all over what? T. Because at this point here, we have time T. And this is the origin here. Okay. Now, how do we get retardation? This is retardation, of course. We know that from here to here is coming down, okay? And this point here, we have the negative acceleration. This point is where the object is brought to rest. So it will always give us the negative sign of the acceleration. How do we get the total distance now? So total distance now is not just the area of the trapezium anymore. So it's going to be a combination of three different kind of shapes here. So we can call this shape A, we call this shape B, and call this shape C. Now, if you look at this shape A here, this shape A here is a trapezium. So this point here will now represent that our A. So the area now will give us what? The half into A plus B times the height. Now, how then do we locate the height? What will be the A? What will be the B? Look at this point here. It's not the A. From here, from 0 to this initial velocity, that is your A. Then plus, what is our B? Look at from this point here down to this E. That is your A to E here. That is the B part. Now, what is the height? We take the height from here. Look at the height now. It's no longer the way the other former graph looks. So your height now, this is your H, will now give us OE. So should the case questions come in this form that begins from initial velocity. So the height now is now this, no longer the time. Good. Now we already know the area of a rectangle. We have the length times the breadth. That one is easy. Then it will now give us plus length times the breadth. What is the length now? AB is the length, and the breadth is what? BD or AE. Then plus another area, this another shape here, C. Also, we know that area of a triangle is for half base times height. So area of a triangle, half base times height. Where is the base? Look at the base is what? DC. And where is the height? Look at the height here. B, D. So when you combine the whole of this, that means distance in A, that's A plus B plus C, is our S. That is the total distance. So this is very useful in physics. So it gives us information, it gives us acceleration, it gives us total distance. Average speed is also given to us. So to calculate the average speed or average velocity is the total distance all over the total time taken. So in our next video, I will bring a question that portray this velocity time graph so that we can use it to solve problems as an alternative to the kinematics equations. So if you find this class very interesting, please help us to share this video and do well to like and comment. Bye.